yours. Because again, Wiley sometimes changes the values for different people, but what it's giving me is it's find the area under, I have 6x cubed minus 2 between 6 and 13. So this is kind of 5-3 material. So remember, area, total area, that's essentially telling you that the second equation you're working with is the x-axis. So we want to find where they intersect. So we want to set 6x minus 2 equal to 0. Oh, this number is going to be a little gross. That'll be all right. So we'll get 6x cubed equals 2. So x cubed is equal to 2/6, which is 1/3. Oof, yeah, that's a little gross. But so x is equal to the cube root of 1/3, which is approximately 0.693. Let's take 4 decimal places, just try to be as safe as possible. So about 0.6934, which actually isn't in that interval. So great, I don't have to care about it. That's cool. So since the place where they intersect isn't in that interval, you just forget about it. So otherwise, if there's no place to split it up, so essentially remember when we were finding the places where they intersect, we would then split up the interval that we were given into multiple pieces. But since the place where they intersect is outside of that interval, we're essentially just going from 6 to 13, or whatever interval you're given. So we need to just find out which one's on top of the other in this piece. So if you want to do that algebraically, we can find a number between 6 and 13, whatever number floats your boat. I'm going to pick 10. And you're going to plug it into both functions. So you have y equals 0. That just always gives you 0. I need to slow down a little bit. And then if we plug in 10 to 6x cubed minus 2, we get 5,998. Which of those two is larger? 5,998. If you were to do this graphically, 6x cubed minus 2 looks like this very badly, where this would be the 0.69. So if we went all the way over to 6 to 13, you know, all the way out here, that's just going to keep going upwards forever. So while this is a very, let me make that a little better. Well, no, because then just pretend that that's what it looks like. So, you know, 6 and 13 would be all the way out here. And hopefully it makes sense what I'm trying to say. The x cubed thing is going to be above the x-axis, is the point. So graphically, that would make sense too. So the 10, so since we're going from 6 to 13, I get to pick any number. I can't hear anything. Oh, she already did. So wait, let me wait till she pops back in because she had the same question. Come on. Can you hear me now? Okay, hopefully. So we're going from, nope, apparently not. Okay, I'm just gonna answer the question. So we're going between 6 and 13, and I wanted to figure out which function's on top of the other. Now I get to, just like when we were doing those number lines, I get to pick absolutely any number I want between 6 and 13. So I just liked the number 10, so I chose 10. You could have picked 7, 8, 9, 11, 12, 6.5, 7.25, absolutely any number between 6 and 13. I just happened to choose 10 because I liked it. Can you hear me now, Susan? I didn't mean to say your name that weird, but So this x cubed thing is on top. So that means that the integral we want to calculate is from 6 to 13. And remember, it's always top minus bottom. And with these 0 ones, it's a little silly, but we're going to have 6x cubed minus 2. Our bottom function is 0. So I know subtracting off 0 is a little silly, but we need to do it. And at this point, remember with these ones, you can essentially punch this into your calculator at this point in time. I'll do the antiderivative really quick in case anyone wants to see it. Remember, you still want to be able to do them by hand because I will ask you to do integrals by hand and you will need to show me all of your work to get full credit. But in terms of these area questions, you essentially need to show me all of the work up to the integral. And then once you have the integral, you can punch it into your calculator for these if you want to. But here would be our antiderivative if you were doing it by hand. So that could reduce to 3/2. And this is where we would have to plug in the top bound and plug in the bottom bound. But this integral turns out to be 6x cubed minus 2, 40,883.5. Has it worked yet, Susan? I see you keep popping in and out. Because I assume everybody else can hear me because no one else has said anything about it. But any more questions on that one? Okay, what was the next one? 16 and 6.3. Aha! This is one of the ones that a lot of people are just plugging into their calculators and Wiley isn't letting you. So, and I tried to warn you, but I'm not going to do the exact one because I am just not going to. I'm going to do a random, very similar one. Haha. Gotcha. So if you have something like this, Wiley's going to want you to put it in the exact way. So that means you can't punch it into your calculator because it will give you a decimal and Wiley doesn't want a decimal. So you would need the antiderivative first, so that 4 comes along for the ride. E to the 2t, you essentially keep the e to the 2t, but then remember we have to divide by that k value, or essentially multiply by it as a fraction, plus c from 0 to 2, so we can clean up those constants in the front a little bit. So in one like this, in 16, the k value is a little grosser, but if you just type in 1 over k into your calculator to figure out what it is, it should actually turn out to be a somewhat nicer number than it looks. So at this point, this is when we take our top bound, plug it in everywhere we see a t, and subtract what we get when we plug in our bottom bound. So 2e to the 4 plus c minus 2e to the 0 minus c, because we have to distribute the negative. C's always cancel each other out. You get 2e to the 4th minus 2. E to the 0 is 1. Anything to the 0th power is 1. So in terms of Wiley, this is what they would want. So on number 16, it's going to be a very similar format. This isn't the exact answer, but that's kind of the format that they want on that one, is they want you to do it purely by hand to get the exact answer. And there are a few of them like that. Where did the other one go? There we go. 34. Okay. Sure. Again, might not be the exact one because Wiley gives different things for different people, but... And I'm not writing down everything in full detail. So here we want the area between x squared minus 2 and the x-axis. So this is a version of question 34. So we'll... I mean, I guess. That's kind of similar to the one we just did, but I'll do one with a decimal in a minute. So we want to set these two equal to each other. So, well, remember that the x-axis is the same as y equals 0. So we want to set these equal to each other. Ooh, this one's going to be also a tiny bit nasty. So we'll get x squared equals 2. So x equals plus or minus the square root of 2. The negative power. Oh, okay. Sure. Yeah, we can do one of those in a second. So here, the interval that we're given is 0 to 3. So we don't actually care about the negative one. We just care about the positive square root of 2, which is approximately, what is it, 1.414? Yeah. This is approximately 1.414. Let's even take 1.4142. If I'm going to round a little bit, the more places I take, the better. So since 1.4142 is between 0 and 3, we now need to break up that interval. So we were originally going from 0 to 3, but now that we found this number here, we're going to have to split it up into 0 to 1.4142 and 4142 to 3. Now you can do this algebraically, because remember the next point is we need to figure out which one's on top of the other. So we can do that algebraically. I'll also do it graphically in a second. So if you want to do it algebraically, that's when you pick any number between 0 and 1.414. So I'm going to pick 1 because that seems like the easiest one to pick. You're going to plug it into both functions. Plugging it into y equals 0 is just going to give you 0. Then we've got to plug it into x squared minus 2. So 1 squared is 1 minus 2 is negative 1. So our top function is going to be 0. And then pick a number between 1.414 and 3. So I'm going to pick pretty much the only nice number I could pick in there of 2. You can pick whatever number you want. You can pick 2.214 if you want or whatever. But I always like to choose some of the nicer looking numbers. So if we plug 2 into x squared minus 2, that'll be 4 minus 2 is 2. So that'll be on top. Again, if we wanted to do this graphically, just really quick, that's going to look like this, where this is going to be square root of 2, and this would be negative square, pretend that's a square root. So essentially the x-axis is on top for the square root of 2, and the parabola is on top afterwards. So again, between those two, the graphically and the algebraically, you just need one or the other. You don't need both, but I usually have been doing both just in case people prefer one over the other. I'll pause for a second in case there's a question about what we've done so far. So now we're essentially down to doing our integrals. So we have one from 0 to 1.4142. And then we're going to have one from 4142 to 3. Top function minus bottom function. So in the first integral, the top function was y equals 0. So we have 0 minus x squared minus 2. Now this is one of those cases where it's very important that you put the back function in parentheses, or else you're going to get the wrong number. I always just suggest putting the bottom function in parentheses always, just to kind of save yourself some grief. But this would be a case where it's very important. And then in the second integral, you have that the x squared minus 2 is on top. So we have our top function is x squared minus 2 minus bottom function, which is y equals 0. Now, I know subtracting 0 can seem a little silly, but let's just write it down. Again, at this point, for these types of questions, this is where you could plug it into a calculator. If you were to be doing these by hand, these would be your antiderivatives. So I'll write the antiderivatives down and then the final answers. If anyone wants me to do any more work by hand pieces, just let me know. But I think a lot of people usually just end up plugging it into their calculators. So those would be the antiderivatives. Then you'd have to plug in the top bound minus the bottom bound. But let's see what these are. So integral from 0 to 1.4142. Does anyone need a refresher on how to do it in their calculator? Also, let me know that, because I can do that too. Whatever y'all need. So the first one comes out to be. Need a refresher? Okay, let me just do these real quick, and then I'll remind y'all how to do that. So, calculator. If anyone doesn't have it, oh, why isn't it? Oh, because, right, okay. If anyone doesn't have a TI-83 or 84, let me know. I only really know how to do it on an Inspire besides these ones, but I can probably Google it. But I don't have a fancy emulator for those. Anyway, what you're going to do, and notice I have the little key press history at the bottom in case you missed something that I pressed. You're going to hit the math button, which is right below alpha. It's highlighted in red on the little screen right now. And then you can either scroll down using the bottom arrow key to number 9, or you can just hit the number 9 on the number pad. And if you have an older calculator, let me know and I can tell you I can remind you how to do it with the older calculator. But with a newer calculator, it should pull up something that looks like this. So say we wanted to put in one of those two integrals we were just looking at. So we had one from, say, 0, and then you press the up key to get to the next bound. And then it was, what, 1.4142. What was the bound? Integrand there. 0 minus. Okay. And then our integrand was 0 minus. Now, really important, whenever you want to do a variable, whether it's an x or a t or a z or a q or whatever, absolutely any variable you ever want, you need to press this variable key. It's right to the right of the alpha key. Even if you want a t, just make it an x in your calculator. Like, you don't care about matching the variable to the thing on the page. So it was x squared. What was it, minus 2? Yes. So you punch in your thing you want to integrate, scroll over to the very right, and then hit that variable button again. And then enter. So that was just one of the two. You'd have to then type in the second one. But that's how you do it. So the main thing, math 9. Math 9 is how you get to the integrand, the integral calculation screen thing. Okay. So that's that one. So I want to do an e to the something with a negative exponent. Sure. So again, not the exact one you were asking for, but now it's got a negative exponent in here, so yeah, sorry. And over. I'll leave that up for a couple more seconds. Also, one big thing while I'm here, a strange thing that I see a lot of people doing over the couple semesters I've been teaching this class. So what I've done here is I've done a little bit more work than I would expect of you if you have a calculator, because I write down the antiderivatives. So I've written down these antiderivatives here. With these area questions, you don't have to do that. If you have a calculator that can do so, you can just type in the integral. But remember, the thing you're typing in is the thing up here. A lot of times I'll find people finding the antiderivative and then integrating that. That's not what you want to do. If you're using your calculator, you don't need to take the antiderivative at all, okay? So the antiderivative is only used when you're not using your calculator. If you're using your calculator, you don't need to worry about an antiderivative. All right. So hopefully we're good. Let me know if I need to go back up. So for this one, antiderivative, there's nothing in the front, so nothing's going to come along for the ride. We're going to have e to the kx, or kt in this situation, kind of come along. And then we have to divide by that k value, so we're going to divide by that entire k value. Even though it's negative, it's just going to come with us. Plus c from 1 to 2. Now, 1 divided by negative 0.5 would end up being negative 2. Oh, maybe I know what's tripping you up, possibly. So if we plug in our top bound and subtract what we get when we plug in our bottom bound. So this one's going to come out to be a tiny bit more complicated. The answer is going to look more complicated than some of the ones on Blackboard, but that's okay. So we'll get negative 2 e to the negative 0.5 times 2 is negative 1. The c's are going to cancel each other out. When we distribute that negative, it's going to become a positive because we have a minus a negative. 2 e to the negative 0.5. Now, in terms of Wiley and like exact answers and all that jazz, you can totally leave it here. Like, just because it turned out to be a negative exponent, you don't need to bring it into denominators or anything like that. You can just leave it as a negative power. That's perfectly fine. So this would be an acceptable answer for this question. So yeah. That was the ones that are on there. Anybody else have any other questions, or like not even a specific question, just like a, hey, can you do this type of question? Because otherwise we've got about 25 more minutes and we'll go on to other notes. I'll wait a couple seconds in case people are typing. Yeah. Total area, do you really want a total area or an area between two completely different types of functions that aren't the y-axis? Or one of each? I don't really care. But before I can do both, I can do whatever you want. One of each? Okay, cool. Sure. So let's see. Whoops. Find total area under let's do x cubed minus 8 on 0 to 4. Sure. So total area or area under anything that says something like that is going to be essentially if you're not officially given a second equation and it says area in it. The second equation is y equals 0. So we need to find where these two things intersect. So x cubed minus 8 equals 0. So x cubed equals 8. Cube root of 8 is 2. And just positive 2 because it's an odd power. So we get 2. So essentially the interval we're given is 0 to 4. So we're going to split that up at 2. So we're going to be working over 0 to 2 and then 2 to 4. If you want to do this algebraically, pick a point in each one of those two intervals. So I'm going to pick x equals 1 for the first and x equals 3 for the second. You're going to plug those numbers that you chose into both equations. Now again, whenever you plug anything into y equals 0, you just get 0. So the only thing that's really going to change is this x cubed minus 8. So if we plug in 1, 1 cubed is 1, minus 8 is -7. And then, goodness, 3 cubed is 27, isn't it? Yep, minus 8 is 19. And as always, I'll also do it calculator-wise. X cubed minus 8. Oh, I should know what that looks like. That looks, stop it, go away. Sorry, my screen's freaking out. That looks like this, where this is 2. So essentially the x-axis is on top in the first one, which is exactly what our algebraic way says, and the cubic thing is on top in the second, which is also what that says. I think I said this last time, but once again, don't assume that it's going to switch. A large portion of the time it is going to switch, but there are some very rare cases where it doesn't switch, so don't just assume that they will. Haley, I don't think we have. I can do one of those next. Because yeah, I think there's definitely one on the review where it intersects more than once. I can do that one, one like that in a sec. So now that we know which function's on top of the other, we're ready to set up our integrals. So we're going from 0 to 2 in one of them, and from 2 to 4 in the 2 to 4 in the second one. So it's always top minus bottom. So in 0 to 2, 0 is on top. So we have 0 minus x cubed minus 8 in parentheses. And then x cubed minus 8 minus 0. And I'll even put that in parentheses just because. I can do the antiderivative if anyone wants, but otherwise I'm just going to write out the answer. 12. 4. 44. 56. So the answer to that one would be 56. So when would they intersect more than once? Let me see. Okay, yeah, let me just do this one that I did with my other class. You don't have to draw the graph if you do the algebraic way. If you don't do the algebraic way. So if you want to use the graphical way, but you don't want to draw it, I at least need you to say used graph to find top slash bottom. I know that seems silly, but I need you to tell me that you know that you had to find which one was on top and which one was on the bottom. And I understand that sometimes people just use the graph to do that. So I just need you to state that that's how you found which was on top of the other. I pretty much always include that in my instructions as well to make sure that you remember to do that. But yeah, if you use the graph way, you just need to tell me that you do the graph way. So let's do one where it's two completely different functions that intersect more than once in the interval we're working over. So, and then we'll do the one you asked for, Emily. So let's say we want to find the area between 4x minus x squared. And actually, hold on one moment, please. Okay. For some reason, I thought this was on the review, but it's not. So that's good, because I don't want to do something that you'll already see. And y equals 3 on. That doesn't look like on. Now this one's going to get a bit tedious because it intersects more than once, so we have to split it up into multiple pieces. But here we go. So we want to set these two equal to each other. 4x minus x squared equals 3. Personal preference, I like the x squareds to be positive because I think that just makes it easier than having to factor out a negative. So I'm going to swing everything over to the right. So add x squared, subtract 4x, and the 3 just kind of chilled over there. Now we want to set that equal to 0. We could use the quadratic formula if we really wanted to, but this is factorable. Two numbers that multiply to 3 and add to -4 would be -1 and -3. So this breaks up into x minus 1 and x minus 3. So we get x equals 1 and x equals 3. So notice that 1 and 3 are both in that interval that we're working over, so we're actually going to have to break this up into 3 different pieces. Because we always need to start and end at the actual interval we're given. Also, note, if we're not given an interval, we create one with the intersection points. So there's a few of those on the review where you're not actually officially given an interval. So say I didn't give you this interval 0 to 4 here, then you would just be going between 1 and 3. So if you're not given an interval, you use the intersection points. But anyway, so we essentially have to start at 0. We're going to break it up at 1. And then we're going to break it up at 3. And then we have to go all the way till 4. So we're going to have 3 pieces for this one. I'm gonna like speed through the algebra way because I think most people are gonna use the graph way, but if you want me to slow down a little bit, I can. But so we're always gonna compare it to 3. And then if we plug these values in here, and I'll do the graph way in a second. I'm just speeding through this a little bit. So if I remember from my other class, that was 1.75, and I forget what that one was. But graphically, we have the quadratic. So this intersects at, oh, I don't care where that intersects. And then y equals 3. So they intersect at x equals 1 and x equals 3. So you know 4 is going to be somewhere over here. Not actually where it intersects, I don't think, but somewhere past 3. So essentially, if we're looking at this graphically, which function is above the other, x cubed is on top up until x equals 1. And then the quadratic turns out to be on top in the second piece. And then y equals 3 is on top in the third piece, which is exactly what the algebraic way would tell you. So once you find out which function is on top of the other, you're ready to, nope, it's because the, oh, that's lagging a lot. The x squared term is negative. So remember, going back to the original one, so 4x minus x squared, not the thing that I had when I was setting them equal to each other. So since that x squared term is negative, it's going to be an upside down parabola, if you will. So let me, so this is y equals 3, and this is 4x minus x squared, the two original things. Actually, let me scroll down for the sake of trying to post this later. No, I'll do it. Whatever. I'll go this way. So we have one integral from 0 to 1. I'm going to run out of space real fast. Then we're going to have one from 1 to 3. And then we're going to have one from 3 to 4. So it's essentially the more times they intersect, the more pieces you're going to potentially have to break it up break them up into. So top function from 0 to 1 was the y equals 3. So we have 3 minus 4x minus x squared. Again, this would be very important to put those parentheses around this bottom function. Top function in the second one from 1 to 3 was the 4x minus x squared. So we'll have 4x minus x squared minus 3. I'll put the 3 in parentheses just to be consistent. And then we have 3 minus 4x minus x squared. Again, squeeze that dx in there. And then again, if anyone wants to see the antiderivatives, just let me know. But I believe, I'm remembering correctly from my last class, these actually all turn out to be 4/3. It's just coincidence. So the final answer turns out to be 12. Where'd that other one go? 13 or 14? Oh, one of the fraction doodads. Sure. Questions, concerns on that one? Okay. Emily, I'm kind of going to do what? Oh, yeah, no, I'm sorry. And it reduces to 4. Good Lord. I'm sorry. 12/3 reduces to 4. Good Lord Almighty. Thanks. All right, Emily, I'm kind of going to do a mix of the two, so I'm not going to do them exactly, but I'll do similar ones. And because one of them includes a fraction like integrand and the other one doesn't. So I'm going to kind of mix the two. So, and hopefully it comes out like I want it to. So this could also be dangerous and I might have to do 2 of them because I'll screw myself over. But we'll try to make it work. Let's try this. That should probably work. And say I want to find the exact answer. So again, for questions like this, and maybe I shouldn't say again, maybe I haven't said it at all. You will have questions like this on your exam where it's just the integral and I want you to calculate it. And I do want to see the steps of you doing it by hand. If you just write down a number that I know you got from your calculator, you will not get full credit. So you do need to know how to do these by hand as well. The first thing we should do here is we should rewrite that first term as 5x to the negative third. So whenever you see a fraction with a higher power than 1 in the denominator, you should write it as a negative power. If it's just over x to the first, that's the one that gives you the natural log thing. But if if it's a larger power than just 1 in the denominator, it's not the natural log thing. A lot of people were doing that on their quiz. That's not how that goes. So here, if we do our anti-power rules, the 5 will come along for the ride. We'll add 1 to the power to get -2 and divide by the new power. We'll add 1 to the power to get 3, divide by the new power. So let me just make those, whoops. Let me rewrite this. Now, because I'm going to have to be plugging in those values, it's going to be better to put it back in its positive but denominator form, if you will, with that power. So x to the negative second would be the same as 1 over x to the second. So I can put it in the denominator with the -2. Well, I pulled the negative out front, but, and then 1/3 x cubed. Ooh, the algebra on this is going to be gross, but here we go. So we'll plug in our top bound. This is why I shouldn't think of ones off the top of my head. And then we plug in our bottom bound. Oh, why is that a 1/2? Sorry. 1/3, 2x cubed. 1/3, 1x cubed. So we've got -5/8 minus 8/3. The c's are going to cancel each other out. Remember, that just kind of always happens with these because you would distribute the negative to get minus c at the very back. We also need to remember to distribute the negative here, or else we'll get the wrong answer. So -5/2 plus 1/3. Oh, Lord. So here's how I would do this. Because if we need to find the final answer as a fraction, we probably shouldn't type it into our calculator because that's going to give us a decimal. And yes, our calculator could change it back into a fraction, but let's just try to do this in our brains. Let me take kind of these two and connect them together. I'm going to change that into an over 8. And then we'll group the over 3's together. So I'm going to finagle this around a little bit. Try to keep these, well, if anyone's blue-green colorblind, they're very sad. Let me try red. That's going to make red-green people sad. You know what? Squigglies. And it doesn't matter if people are colorblind. There we go. Squiggles. All right. Now 5/2 would be equivalent to 20/8. You multiply the top and bottom by 4. And then we'll have 8/3 plus 1/3. So we'll have -25/8 minus 7/3. Ooh, I regret. Now we have to make everything over 24. Oh, I really regret. I don't think the algebra on the Wiley ones is quite this bad, but so 25 times 3, because that's how you got to 84, sorry, 24 on the bottom, 8 times 3. So we'll get -75, and then 7 times 8, 56. -131/24. Oh, goodness. Let me triple check. I'll scroll back down in just 1 second. Hold on. I've done something wrong. Where did I go wrong? Let's see. If anyone sees where I went wrong, let me know, because that's apparently not the correct answer. Oh, I went wrong. Wow, where the heck did I go wrong then? Did I type it in my calculator wrong? Add 1 to the power divided by what? The heck? Oh, I see. Pesky negative here that didn't end up here. That's what happened. Oh man, that's really far back. We should make this a plus. We should make this a plus, which would make this positive 15, which would make, whoops, that's a positive, oh, 45. There we go, -11. I'm sorry about that. Missed a negative, and that's why I am as nice as possible with partial credit, because if y'all did that on an exam, you would get most of the credit because you just dropped a negative. But sorry about that. That was a hefty one with the algebra. Any questions on that one? Okay. We only got 4 minutes, so I'm not about to make us do anything else content-wise. But if you have any more questions that you want me to go over in these last 4 minutes, let me know. Emily, any SI things coming on?
I just sent a message in the group me, but I'm just holding my session again tonight and tomorrow, and I'm going to split the review in half, go over the first half tonight and the second half tomorrow.
Cool. Thank you.
Mm-hmm.
All right, if there's no more questions, we can go ahead and be done. I'm not going to keep you here for 3 more minutes, so if you want to leave, feel free. If you have questions, feel free to stick around for a little bit. Otherwise, I'll see y'all on Wednesday. So the grade so far after exam 2 is up there. And I will be posting the cumulative grade after this last exam. If you want, Aiden, if you want like an official, like super at the moment current grade, shoot me an email and I can, I have yet to figure out how to bend Blackboard to my will to make it show the correct cumulative grade. It always messes it up. So shoot me an email if you want like the super duper up-to-date one. Otherwise, you'll have an up-to-date one after this exam, and you have one from the one after exam 2. Yeah, no problem. Shoot me an email. I'll let you know where you're at.